Hey, welcome back to part 2 of my compact cargo bike build. In the last video I showed you the concept for this bike, and then we mostly tackled building the frame and the steering system, so if you haven't seen that you can find a link to part 1 in the description. And this time we're gonna do everything else that's left, which is a lot more work than you might expect, so let's jump right in and start with the biggest task, which is building the folding cargo basket. Each side of the basket consists of 8 parts that will be welded together. I like to do the hardest part first, so I'm starting with the bent sections, and I conveniently planned this based on the same material that I used for the steering rod in part 1, which means I can use my modified bending tool here again. These parts are a bit more complicated than the steering rod though, because they have multiple bends, and getting those bends in the right positions is essential so everything fits. There's a few ways to approach this, but since I already have a CAD model, what I usually do is to measure the length of each section of the path that the tubes are following, both for the straight sections and the bends. And if I transfer those measurements to the tube in the same order, I know exactly where each bend has to start and end. So here's a practical example of that. The first section here is just extra material in case the tube ends up too short for some reason, and the S marks the start of the actual part. B1 is where the first bend begins, the next line is where the first bend should end, then B2 is the start of the second bend, and E is where the tube will be cut after bending. These basic benders unfortunately don't have an angle scale, so I'm using a big protractor to check it manually and just carefully work up to the angle I need. With that, the two rear pieces are mostly done, and I can move on to the front pieces. These are more involved because they have an additional bend, which is also on a different plane, so we have to think in 3 dimensions for this one. I'm doing the first 2 bends the same way as before, which lets me use the rear pieces as a reference to check alignment. For the third bend, the part actually needs to be rotated 90 degrees, and since the bender doesn't give you any reference for that either, I'm just placing a square on top of the die and visually aligning the tube with it here. This isn't the most accurate method, but it works well enough in this case. The second front piece is a classic example for something that's easy to mess up, because if you just repeat what you did for the first one, you end up with 2 identical parts, but we actually want mirrored ones. So in this case, the end needs to point down instead of up. On the last bend, I actually overshot the angle slightly, which can happen quite easily with these manual benders, but with small diameter tubing like this, you can usually just fix that in a vise with a bit of careful persuasion. Next, I'm cutting miters into the rear tubes so they fit neatly with the front ones. I'm using a self-made V-block here, which is similar to the tube blocks you saw in the first vid, but more versatile since it takes different sizes. And now I'm making the straight sections, which are very simple. I just gotta cut them to length and miter both ends. Now we have all the main puzzle pieces on the table, and the next challenge is figuring out how to assemble them straight and symmetrical. This is where the welding table really pays off, because I can use that to quickly build a custom fixture to hold and align everything in 3D space. I'm using 2 large angle blocks and several stops to provide reference surfaces for the important parts of the geometry. And the point of fixtures like these isn't just to hold the parts so you have your hands free, but also to give you a precise reference surface. So if one of the tubes is bent slightly wrong or the whole assembly goes out of square, the fixture should make that obvious, so I don't have to guess or measure anything. Whether you need this level of precision depends on your goals and how picky you want to be. It's definitely not necessary, but it does make things very convenient for me. Before tacking everything together, I still need to miter the joints at the bottom. Since the fixture gives me accurate surfaces I can use for reference now, I can simply measure off of those to determine where the miters need to go, which is usually more accurate than trying to miter the tubes before bending. After cutting those, everything goes back into the fixture where we can now also insert the straight pieces. I'm using a pair of T-nuts as spacers on the bottom here because they just happen to be the perfect height. And with that I can tack the first few joints so the whole thing becomes one piece. For the upper straight section I made a small standoff by attaching two stops together so it sits exactly at the right position while I place some more tack welds. Then I just repeat the process on the mirrored frame on the other side, and having both sides set up like this at the same time is extremely helpful because it makes it very easy to tell whether the shoe halves actually match. Making one part look good is easy, but making two identical parts is where it usually gets challenging, especially if they have features that are curved and angled like on this one. And speaking of it, as you can see on one of the upper tubes, the angle was still slightly off here, but it's only off by a degree or so, which isn't dramatic with these small tubes, so I just clamped it into alignment before tacking. At this point I had to actually climb onto the welding table to reach the joints. But once everything had at least one tack, I could take the part out and add a bunch more before running the final welds. I'm not gonna bother welding these inside the fixture though, because the position is just too awkward for a lot of these welds, and with TIG, comfort is almost always the #1 factor that decides whether a weld comes out clean. Obviously that also depends a lot on your skill, but I usually mess up when I have to weld in weird positions, so I'm gonna do it flat on the table and also use the vise for some spots. While I'm welding this up, here's just a short reminder that if you want to replicate this project, I do offer a full set of plans for the bike, including detailed drawings of every part, material lists, and a ton of extra information, as well as the CAD model. So if you're interested in that, make sure to check the description. Like last time, I'm also running a discount again for a week after this video releases, so if you're quick you can actually save some money. After running full welds, the frame can go back into the fixture one more time to check for distortion, and as expected the ends here pulled in a little bit. And other than that, both sides looked straight enough for me, so the next step is adding the joints. I'm gonna start by making the bushing housings for the falling mechanism. These are made from the same tubing I used earlier, but they need to be cut to a very specific length, which is why I'm doing this on the lathe, which is a bit more accurate than the bandsaw. Now I'm gonna make the stop tabs, which we need 4 of. As usual, I'm machining a stack of them at once by sandwiching the pieces together, which saves a lot of time and makes sure they all match. The bushing housings get welded to the bottom ends of the basket frames, and I'm only tacking them on the outer sides because the top surface needs to stay flush, since that's where the stop tabs will be welded. To attach the tabs, I'm using a parallel clamp as an improvised fixture. I don't use these very often, but for situations like this they're super handy because they have flat faces on all sides, which makes alignment much easier. One downside of working with aluminum is that it isn't magnetic, so you can't use welding magnets the way you would with steel, which often makes it necessary to come up with little tricks like this one to hold small parts in place. Once the position is right, I can tack the tabs in place and then weld everything together, and with that the basket sides are mostly finished. Next up are the joint brackets that will eventually be welded to the down tube. I could have milled these out of solid blocks, but that would have wasted a lot of material, so I'm starting with a U-shaped profile instead. These usually only come with a square cross section though, so I'm milling them a bit shorter first to match the dimensions I need. And after that I can slice the profile into 4 brackets, each of which gets a hole on one side, a thread on the other, and some rounded edges to clean up the look. As with the steering joints in part 1, I'm using 3D printed bushings for the folding joints as well. These get pressed into the sleeves, and just like before I printed them slightly undersized so I can ream them to final dimensions. When combined with the shoulder screws, these joints are very easy to assemble and have essentially zero play. The shoulder length exactly matches the inside width of the brackets, and the bushings take up the remaining space, so once you screw it together it simply lands in the perfect preload range without any fine tuning. And if a bushing ever wears out, printing a new one takes a few minutes and costs almost nothing. With everything ready, I can now mount the brackets to the frame, and a nice side effect is that these pieces happen to sit in high stress areas of the down tube, so they essentially act as gussets and add some additional strength to the frame while also serving as the mounting points for the basket. For the front brackets there's a minor complication though, they overlap the welds on the side here. I initially thought about cutting a clearance notch into the bracket, but since the brackets act as reinforcements anyway, grinding that weld flush in this small area makes more sense. And once everything fits nicely, I can weld the brackets onto the frame for good. Now it's time for the first real test fit of the basket. Thanks to the shoulder screws and bushings, assembling this is extremely straightforward. There's no need for washers or nuts and no fiddling with the adjust bint, and everything bolts on from the outside, so there's no need for fumbling around underneath the cargo bed either. You might notice that the sides are still drooping down a bit now, and that's actually intentional because I didn't want metal on metal contact between the stop tabs and the down tube. Over time, especially with vibration, that would most likely cause wear to both the stop tabs and the down tube. So instead I included a small gap which will be filled by these 3D printed bumper blocks. These act as consumable parts that isolate the motion and soften impacts, which should reduce rattling. and they can also be tweaked in thickness to compensate for minor inaccuracies in the basket frames. They just get screwed on here and they now define the final movement range for the joints. For the first version I printed these from regular PLA just for testing, but it might also be interesting to try TPU or similar flexible materials for extra cushioning. Most of the 3D printed parts for this project were made on my new Prusa Core 1, which now lives in this closet at home, so I can do prototyping without going to the shop. I call this my magic closet because I can just send print jobs to the Core 1 wirelessly and I can't hear it at all in there. So when I come back sometime later I just magically have new stuff in my closet. And so far this has been one of the most reliable and easy to use printers I've tried. So if you want to support a European company, I think this printer is a really good choice for both beginners and pros. But anyway, for now the basket is finished, so I'll take the sides off again. We will be adding some covers to these later, but structurally everything is fully functional, so let's move on to the next part. The next thing we're gonna tackle is the kickstand. I've said many times before that having a good kickstand is one of the most important features on any cargo bike. On my big long john builds I made elaborate custom stands, but on shorter and lighter bikes a high quality double leg stand on the rear can be sufficient, and I think this bike still falls into that category. This frame doesn't have a mounting point for a kickstand though, so let's add a custom one. I don't have a perfectly accurate CAD model for this part of the frame, so I'm gonna wing it to some degree and figure out the position directly on the bike. For testing purposes I prepared this plate that will later become the mounting bracket, and I can now clamp that to the chainstays to roughly check the fit. Putting it down here kind of works, but the angle is a bit too flat, and as you can see this causes the kickstand legs to almost touch the ground when folded up. That's partly because the rear wheel is so small, but mostly because, as I showed you in part 1, the donor frame is angled backwards quite a bit to adjust the geometry for the smaller wheel, so the chainstays have kind of an unusual angle compared to most normal bikes, and that's not what these stands are designed for. To fix that, I'm actually gonna mount the plate between the chainstays rather than below, which is how it's done on most frames, and I can then also tilt it slightly, and that should give us a lot more ground clearance. So it's time to shape this plate now. I'm marking the outline and then I'll just cut it roughly to shape and then file it until it fits. So like I said, this is more of a hands-on approach for a change. One more thing I added is a small channel on the underside, because without these edges, this type of stand tends to twist sideways since they just have a single mounting bolt. Now I can test the angle one more time, and then I set up a little fixture again to hold the plate at the correct position, and then it's time to weld it on. And as you can see, we now have much better ground clearance and a very solid mounting point. Next are the disc brake tabs. In the previous video I already removed the old V-brake glasses from the frame, so now we need some way to install brakes, and I'm going with the ISO disc brake mounting standard here. There's a bunch of other standards, but ISO tabs are very versatile and it's the easiest system to retrofit, but I might also be slightly biased here because I happen to already have a jig for it. I made this jig myself some years ago, and it's based on the Incepi jig, which you can also buy and which is much nicer than this knockoff I made. But this works well enough for my purpose, and like most brake jigs it uses a dummy axle as a reference, which I also made. But you don't necessarily need a dedicated jig to retrofit disc brake tabs. I've done this in the past by just using an old brake caliper and a cardboard template, and I'm gonna link one of my old videos in the description so you can see how that works. That method is a little bit of a dirty hack, but if you use it carefully it can work surprisingly well. As for the brake tab itself, these are relatively easy to make since it's basically just a plate with two holes at a defined distance, and the rest of the shape has to be refined for each frame by hand anyway. But in this case I happen to already have a bunch of blanks that a very nice viewer of the channel cut for me on a water jet. He also built the only copy of my full suspension cargo bike that exists to my knowledge, so shout out to Jan here. I designed a bunch of different versions with slightly different shapes, so I can pick whichever fits best depending on the frame and fork. And by the way, there's some templates of these included in the plans that you can print out and stick to some sheet metal to cut them out manually. By trying different shapes and positions, I can figure out what works best for this particular frame. For example, I want to avoid getting too close to this fender mount here because I want to keep that usable. So I'm going to use a tab with a steeper angle in the back. You can theoretically install these anywhere along the reference axis, but it generally makes sense to put them as close to the frame as possible to get the best stiffness, while still leaving space for the bolt heads. Once I've found a position I'm happy with, I can just transfer a line where it intersects the frame, and then I can start the process of trimming it down until it fits. This is always a process of trial and error, so you just gotta slowly work up to the final shape. But luckily these jigs allow you to work on the tab while it's still in the jig, so this process doesn't actually take that long. And now that we have a clean fit, I can weld it on. Some people insist that adding a diagonal brace between the chainstay and the seat stay here is necessary, so the braking forces don't collapse your frame. But I'm not doing that because in my experience it works completely fine without, and I've never actually seen this failure happen, so it seems to me like it's one of those mythical stories told in online cycling forums. But anyway, the frame is now ready for disc brakes, but we still need to prepare a brake tab for the fork. Luckily I can just use the exact same jig again with a different axle and some spacers. I'm skipping the details here because it's the same installation process as on the frame. I did actually have to make another modification to the fork, but once again that would take a bit too long to explain for this video, so you will be able to see that in the deleted scenes video on my Patreon. Once the front tab is welded on, I can do a test fit with an old brake, and it looks like everything lines up nicely here. And since I know somebody's gonna mention this in the comments, yes, the wheel in these shots is using a radial lacing pattern for some reason, which is a really bad idea in conjunction with disc brakes. I didn't build this wheel myself, I bought it like this because it was really cheap and has a pretty nice hub, and I only noticed the lacing after it arrived. So for anyone concerned, I did relace this wheel with a cross pattern a few days after finishing the bike. With the brakes sorted out, the next step is adding supports for the cargo bed. These are simple pieces of tubing with a hole drilled through them that get welded to the sides of the down tube. The cargo bed itself is just a sheet of laminated plywood that I'm gonna add a few more features to later. You can just install the bed with bolts and nuts, but in my case I chose to put in some riv nuts so I can bolt the bed on without any nuts. For the next chapter we're getting into the smaller details now. The very last parts I need to weld onto the frame are the cable guides. You might remember that I removed the original guides from the donor frame, partly because they were ugly and partly because they didn't suit the new brake and drivetrain layout. Specific aluminum frame building hardware is hard to find here though, so I decided to just machine my own guides. These go on the bottom of the top tube and on the chainstay and will hold the brake line for the rear brake and the shifting cable. With that out of the way, the actual building phase is pretty much over now and we can start assembling the bike. I'm starting with the fork, which got a coat of paint off camera, and then I'm reassembling the steering system I made in the last video. Next, I want to mount the battery base. I marked out the positions beforehand, and like I mentioned in the first video, one reason I used such a thick wall tube for the steering tube is that I can now actually tap threads into it. With aluminum you can't brace on bosses like you can with steel, and I can't put riv nuts inside either because they would protrude into the steering shaft, so tapping threads directly into the tube is the most convenient solution here. And yes, I'm drilling slightly off from where I put my marks here, and at the point of editing this video I have no idea why I did that, but there was probably a reason because it worked out fine. Now let's do some wiring. On my last build the wiring was almost fully internal, and the amount of extra work that caused was enough for me to never want to do it that way again. But I do at least want the main bundle of cables from the motor inside the down tube because it makes things much cleaner. So I'm marking out an entry point, drilling it with a step drill and then doing the same under the battery base for the main power cable. Of course I deburr all holes thoroughly so the cables don't get cut. But I also printed some small collars that snap into place and give the edges a rounded surface for extra protection. Fishing the cables out of these holes is always tedious because there's not much space inside the down tube. But I don't want to make the holes any larger than necessary for structural reasons. Eventually I was able to fit everything through, and as last time the Bafang motor fits quite neatly in this configuration, even though it's not really designed to be integrated like this. After that I can install the main retaining nut. These motors come with a cheap stamped wrench, but in my experience you can't properly install the nut with those. So I cut apart the old wrench I had and welded the end onto a tube and turned it into a makeshift socket so I can actually use a torque wrench. And I posted a short about this a while ago if you want to see that process. Now I'm connecting the battery base to the motor and pulling the connector out through the hole I made before. I also need to feed the main controller cable through here, and that's the one that connects everything on the handlebars to the motor. Inside the battery base I've branched off the main power line with some Wago clamps to connect the front headlights, so it's a pretty tight fit in there now. Once that's closed up, I can install the base on the frame and mount the headlight. And as usual I'm going with the Busch und Müller headlight here, because they just make the best lights in my opinion. Now I'm installing the front brake, and I'm gonna run the headlight cable alongside the brake line here. I could have made more of those welded cable guides like the one I used on the top tube, but those took more effort than it looked, and since this part of the tube is thick enough for threads, I decided to go with some 3D printed cable guides instead. This actually turned out to be a really decent solution and is very quick to implement. And the reason for the cable crossing over here at the bottom is because it needs to come up at the other side to join the main harness. I'm also installing a little tail light, but before I finalize all of that I need to install the cockpit. So here we got the shifter, both brake levers, 2 brake sensors and the display for the motor. Now it's also time to install the rear brake, where the new cable guides come into play. And then I can move on to the drivetrain by first attaching the speed sensor to the chainstay. So I usually build all my bikes with external gears, which is just my personal preference. But this project is a bit of a special case. I decided to use an internal gear hub here, in this case a Shimano Alpine 8-speed hub. One reason for that is that I wanted this bike to be easy to maintain, and these are very reliable, but the bigger reason is once again the fact that we're using a non-standard frame here, which often leads to problems with standard bike parts. An average long cage derailleur simply doesn't work well with such a small wheel because the cage would hang very close to the ground and can even collide with the tire in low gears. The alternative could be a short cage derailleur, but that limits you to a tiny cassette, which would limit the gear range, and even then you would still have issues with the chain line around the kickstand. So the internal gear hub is by far the path of least resistance here, which is why you see this solution on many 20-inch bikes. I'm also installing a shift sensor that cuts power to the motor when the cable moves. Like the brake sensors, this one is optional, but in my opinion it's almost mandatory for preserving the hub. This weird looking yellow tool is a gauge that helps you set the correct distance for this cable clamp that engages with the hub. You can buy it for 15 bucks from Shimano, or you can print it for like 10 cents. Now I can add the chain ring and the cranks, and because we're using vertical dropouts, we also need a chain tensioner and of course the chain itself. And just like that, we have a working drivetrain. With everything connected, I can finally stuff the rest of the cables into the down tube and close it with the 3D printed plug. This has one opening for the cables on top and another one at the bottom, so water can drain out, because somehow water always finds its way into bike frames. Now the last steps are to finish the cockpit wiring, installing the brake sensors, and I also cleaned up the cable routing, and I decided to hide the main harness inside this fabric cable sleeve. I also drilled a few last holes for some more printed cable guides, and these allow me to tuck everything neatly into this corner behind the battery. And considering this is mostly external cable routing, I think it actually looks pretty clean now. We're almost done now, but I think the remaining steps are still relevant, so let's finish the last details. The folding basket is structurally done, but right now it's still just a bare frame, so the next step is giving it some kind of skin. I'm using a PVC-based tarp material that I've used in countless projects. This stuff is waterproof, easy to cut, but impossible to rip, and thin enough to work with simple tools. I transferred the shape onto the tarp and then cut out the side pieces here and then punched a bunch of holes around the perimeter, which then get fitted with these small grommets. Once all the grommets are installed, I temporarily fixed the tarp to the frame with zip ties, and these are just to hold it roughly in place while I weave an elastic cord through all the holes. When that's done, I can tie the ends together and remove the zip ties, and the tarp stays in place very nicely thanks to being under some light tension. It actually has enough stretch to accommodate for bulky objects, but still holds the shape nicely. For the front and back panels, I ended up using a slightly different approach because I want those to be removable. So I cut matching panels from the same tarp, but instead of round holes, I'm punching two holes at a certain distance, and now I can cut out the material between them to create these slots. To avoid the slots getting deformed out of shape when under tension, I printed these custom long grommets, which are going to let me use Velcro straps instead of the cord you just saw. These can also be pressed together with a light interference fit, but I don't think they'd stay in place for long from just that, so I also decided to give them a few small dabs of superglue so they don't work themselves loose. And to avoid gluing myself to the workpiece, which I've done more times than I'd like to admit, I also printed a small pressing tool as well. After searing the edges of the top to prevent fraying, the pieces can now be installed. The upper Velcro straps are actually being attached to the basket frame using some small rivets to keep them from sliding down. And then by tightening the lower straps we can put a little bit tension on this as well, so it's nice and smooth. I'm actually pretty happy with how this solution came out, considering I designed most of it on the fly without a fixed plan. The panels open and close freely without interfering with the folding mechanism, and the basket is now closed pretty nicely all around, while still enabling you to remove the front and back piece easily. Speaking of closed, we also need a way to actually keep the basket closed when riding, and who would have thought I did some more 3D printing off camera, which resulted in these two end plugs for the basket. One of them has a hole in the bottom that I can insert a piece of rubber string into. Then I can just tie the two ends together and pull the knot into the hole, and you can probably see where this is going. This is now inserted into the back of the basket here and acts as both an end plug and a lock at the same time. The other side gets this plug, which conveniently has a groove that matches the rubber string. And now to close the basket, we just gotta loop the string around the other end, and that's it. The solution doesn't require any moving parts or mechanisms. It keeps the basket closed reliably even on bumpy roads without any rattling, and it's super intuitive and easy to use. So as much as I like to overcomplicate things sometimes, I think this is a good example for when less is more. The only downside here is that we do have metal on metal contact at the steering tube here, which is why I put some protective tape on the frame for now. That problem is easy to solve another day though by adding some kind of rubber bumper, but for now this should be fine. There's also a little special feature that I added to this bike, which is purely optional and once again led me to misuse my milling machine to cut wood. This cutout in the cargo bed is to make space for a lashing ring, which as you can see sits below the surface, so it doesn't get in the way, and this is to provide an additional point for securing dogs and potentially other things as well. I suppose whether or not you need this depends a lot on the dog and some other circumstances, but I figured it wouldn't hurt to have it just in case. Obviously it would be pretty annoying if this ring keeps bouncing around on rough roads when you're not using it, so to fix that I just glued a little magnet in here to keep it from doing that. I also added a fender in the back with yet another custom 3D printed part, because once again this frame is weird, so the normal mounting hardware doesn't work here. And last but not least, I'm now finally replacing the temporary bushings in the steering system with some bushings that I made out of a more suitable material. And I'm also installing all the steering parts with Loctite for the final installation to make sure nothing is able to rattle itself loose. And with that, we are basically done now. The two most common questions I get about cargo bikes by far are how much does it weigh and how much can it carry. At least for one of those questions I can give you a pretty definitive answer, because including the motor, the battery and everything else, I somehow managed to keep this under 30 kilograms, which might sound like a lot at first, but for a fully electric cargo bike that's actually surprisingly light, especially considering that the tubing I used is completely overkill. As for how much it can carry, this question is a bit hard to answer, because giving any kind of definitive answer here would involve doing extensive analysis that I'm not qualified for, as well as destructive testing in a lab, but besides that it's also tricky to define what too much weight even means. In my experience, the limiting factor for cargo bikes isn't at which point the frame breaks, but rather at which point the handling becomes so sketchy that it's not safe to ride anymore, which happens way sooner. This obviously depends a lot on the rider, but just to give you a number, with this being a small bike, I personally wouldn't put more than about 60 kilograms into the cargo area, which would be plenty for most things you can fit into the basket anyway. Speaking of the basket, as you can see, even when it's empty, it actually doesn't bounce around that much, but if you really wanted to stay put, there's actually something I haven't shown you yet, which is these locking bars. These are just some tubes that I fitted with some more 3D printed plugs at the end, which can be conveniently carried with you inside the basket thanks to these transport clips. And you can clip these onto pretty much any point on the basket, which will keep it locked tight in an open position, but that's actually not their only purpose. For example, you can also put one in front here to keep your load from sliding out, but they can even be used to give the cargo bay an extra level. So if I install them on top, I can use them to place additional objects on there that would otherwise fall inside, which can be really useful for carrying bulky stuff. You can even clamp them to the inside of the basket and create an extra level here. For example, if you want to keep something on the bottom from getting crushed. And I'm sure you can come up with many other uses for them. Before we finally conclude this, there's one other feature I want to show you that I hinted at in the very beginning. I didn't want the entire point of this bike to just be the folding basket, so I made sure to design this in a way where it also works without it. If you need to carry stuff that's wider than the basket, or you just want to put a large box on it, you can simply remove the sides by just taking out the 4 screws. The bike then converts into a normal flatbed style cargo bike that you can put pretty much anything on. And what this also means is that if you want to build a similar bike, but you don't need the folding basket, you can save yourself a whole bunch of work by simply skipping that whole step. As mentioned, the cargo bed fits a standard Euro crate, both sideways and lengthwise, and it can also carry a lot of other bulky stuff in this configuration. And in those cases you can use these slots here, which are there to attach various kinds of hold-down straps to secure your stuff. And with that, let's finally check out the finished product. Before we wrap this up, I'd like to give you a little verdict here as usual. This project ended up being a lot more involved than I initially thought, mostly because of that basket. I know some people think the folding feature is a bit pointless, and when I started making this I also had my doubts about it, but it actually turned out to be super useful in all sorts of situations. Due to the basket and the short length, this bike actually manages to fit into spaces that I could never put my larger cargo bikes in, and even in spaces where it wouldn't fit if the basket was fixed. So while it's true that the handlebars are still the widest point on the bike, for stuff like parking it inside a bike shed or a storage room, folding it up actually makes a huge difference. And although this might be more for a psychological effect, it also feels snappier to ride when folded up and makes it easier to squeeze through all kinds of tight spaces. This bike has been in use for about 6 months at the point of releasing this video, and I haven't found any major issues, so I would definitely call that a success, and considering how well it works, it's already got me thinking about making some more compact designs like this. Anyway, if you got any questions or ideas for what I should build next, feel free to drop them in the comments. Unfortunately, it seems like fewer and fewer people are interested in this type of long-form content nowadays, so if you want to help me keep making these videos, you can always support me on Patreon. And that's it for this one. I hope you got something useful out of this video, so thanks for watching and see you next time.